Hi, and welcome back to Leslie's Lab. In this episode, we're going to take a look at using these vacuum fluorescent displays that are commonly found on eBay with a Raspberry Pi Zero. These are pretty cool things to be able to use. You know, they're pretty cool if you want to do things like signage or whatever. You know, you could connect it up to your Raspberry Pi and have it display things like your home network settings, like your IP address. You can have it display the time and date. You can scroll text backwards and forwards. You can even make a clock with it. So let's get it on the bench and let's go. So this is the BA63 customer display on the bench. They're very easy to get apart. Everything just unclips. Put some clips inside to release the display. And that's it. So on the front of the PCB here, all we really have is the vacuum fluorescent display itself. There's a vacuum sealing pip at the bottom there. We'll have to be careful of when we come to solder to it. The back of it's kind of obstructed by this plastic shield, so we'll just remove that. So now that all the plastic's off, we can see what's going on here. At the bottom we've got a PS2 style connection that provides power and our serial. We've got an inverter section over here to provide the high voltage for the display. A couple of display drivers at the top there with a fuse and some caps. We have an EEPROM here, which actually could be pretty interesting to maybe pull out and read. I suspect that the characters for this display are actually stored on the EEPROM. And then we have a TEMIC microcontroller that we'll be interested in shortly, that basically controls the entire display. To power this thing up, we require 12 volts, and we could use the PS2 connection at the bottom. This is actually detailed in a manual if that's what you want to do, but I'm just going to solder some wires directly to this using the exposed pins at the bottom of the connection there. So I'll just grab the soldering iron and we'll solder it up. So we'll just apply a bit of solder to these pins. And then we'll tack on our power. If you want the details of which pins do what, there's a document on GitHub. When we come to download the code for this, I've actually uploaded photographs of where to connect these on. So that's it. We've got our ground in there, and we've got our 12 volts positive. And all we need now is power. So I'll just fire up the power supply. So what we see is when the display starts, we get a flash on the display of all the pixels lit. Let's just disconnect that one more time and reconnect it in, and then it goes out. Now obviously this isn't very exciting. There is actually an inbuilt test function built into this. If we take a look at the bottom here, there's 5 positions, five jumper areas essentially. And if we solder a bridge across jumper 5, which is very oddly on the left hand side, it goes 1, 2, 3, 4, 5. We can actually get all the characters to display when the display starts. So let's do that just now. So just disconnect the power. Just need a short piece of wire, and we'll just jump at position 5. I'll do a bit of a rough job. I don't really care because I'm going to pull it straight back out. So we'll just use a bit of wire wrapping wire to jumper that connection. And there we go. This time when we start the display, we'll expect to see something a little bit different. So let's just hook that up. So now it's going through its test sequence. (1997) vintage. Awesome. We'll just disconnect that. We'll take a look at some of the other bits and pieces now. These displays run off serial. Serial requires 12 volts, and that's not something that the Raspberry Pi can supply. Additionally, there's oddnesses with, well, literally oddnesses with how the serial is configured on this. The serial that this spits out is odd parity, and the Raspberry Pi just doesn't understand what to do with that. Fortunately, these jumpers along the bottom here allow us to set the parity, so we can actually just turn that off so that it's compatible with the Raspberry Pi. So let's do that just now. We'll remove our test link. And I'm going to put a very tiny jumper on position number 3, which is the middle. I need tweezers for this. I've just made a very small loop of wire. So small I can barely grab hold of it. So we'll just come in there, tack that on. We should be good enough for that. And that's our display now configured for no parity. Awesome. The last job that we need to do with these displays, in order to get the Raspberry Pi to talk to it directly, we need an appropriate voltage level. As I've said, this is 12 volt serial. There's a couple of ways we could do this. We could maybe build something for the Raspberry Pi that changes the voltage levels. But if we flip this display over, we've already seen there's a TEMIC microcontroller. What does it say on it? TSC 80C31-16B. If you look up the datasheet for the TEMIC microcontroller, we can actually see that it's got TX and RX pins. So we're going to solder to pin 5 of this microcontroller, which is its receive pin, and then we can transmit data to that. Conveniently, there's a little pad, an exposed pad on the board. I suspect it's a through hole. There's a multi-layer board, maybe 3 or 4 layers in there, and we can just solder directly to that. For this job, I like to use wire wrapping wire. So there's some wire wrapping wire. This is, particularly small diameter wire. It's very easy to solder to small connections like this. I suppose we could solder directly to the chip pin, but if we have a pad on the board, why bother? So very quickly, we'll just come in here and tin that pad. Again, on my GitHub, there's high resolution, or at least better pictures of these connections. So just come in there very carefully and just tag that to it. Job done. So now we have our serial input line that we can play around with. So that's about it as far as electrical work is required for this display. Let's go and get the Raspberry Pi Zero and hook this thing up. So I've got the display set up underneath this monitor here. It's been powered up already. We have a Raspberry Pi Zero, and I've soldered a couple of leads onto this. One of them is the ground, and the other is the TX pin from the Raspberry Pi Zero, feeding our RX pin of our TEMIC microcontroller. Obviously we need code, I suppose, to drive this thing. So I'm just going to pull the code I've put up on GitHub. I'll link in the GitHub account down below, and you guys can go and clone this repo as well. So if we do an ls real quick, we can see our RPI repo there. Just hit tab. Awesome. And if we do a quick ls, we've got a number of bits and pieces in here. We've got the usual license and readme. There's a folder called media. All that has in there is images of where to solder onto the board. What we're interested in is in source. And so if we do a long listing in there, with a number of scripts, just mostly to prove that the display is working and to try out a few things. So we've got BA63 Clock, which is just a clock. We've got a couple of scrolling scripts that will scroll text backwards and forwards across the screen and so on. We've got a script here called BA63.Pi. Let's take a look at it. This is just a test script, but it's a simple script, so it's easy to explain. So we'll just open that up with Nano. So we've got the usual imports at the top. I don't think we actually need time for this one, but anyway, we've got import serial, which is what we need. We've got our serial setup. So dev TTYS0 is our Raspberry Pi native serial port. Baud rate 9600, it's the fastest we can get out the display. Parity on and so on. The next sort of thing here is we create a variable called region and pass it this. If you read the manual for the BA63 display, which again is linked in down below, there are a number of escape sequences that are used to set various properties of the display. This first one here sets region. That's it. So we just send it /033, which is the escape character, followed by R00, which sets the region to USA. I just wanted the standard ASCII character set. There are others, you know, if you want Japanese or Greek or French or something, you should be able to get those. And then we just write it. We just do a serial write the region to display, and then that's set. We've got an example of how to clear the screen. We just send it escape bracket 2J. It sends the escape sequence to clear the screen. All of this code on GitHub is quite well commented, so you should be able to work out what's going on quite easily. To start writing to lines of the display, we have to send these escape sequences. This says 1:1H. This says start writing to the first line at the first character, i.e. way over on the left there. And the second one says write to the second line at the first character. You can actually specify where on the screen you want to put anything you like. So again, read the manual, have a look at these things. Down at the bottom, dead simply, we create a string here that says Leslie's Lab in it, and we do a serial write line 1, which is this escape sequence, plus our string, so it just sends the whole lot in a wanna, and then we do the same thing for line 2. And that's it. I mean, it's really dead simple to control. We'll just exit that, and we'll run it. And very excitingly, it says Leslie's Lab with a bunch of dots at the bottom. In a couple of seconds, it'll time out and clear the screen. Awesome. So far, so good. I mean, obviously, we want to have things animated. So we've got a couple of things that do animation. We've got a BA63 clock. Let's just run it. We can always take a look at the code after. Oops, would help if I could spell Python. So this is an example of a clock that displays the current date and time. If you've got if this is a Raspberry Pi Zero, I don't think any Raspberry Pis have built-in RTCs, but it can go and grab the time once it's connected to the internet, and that's what it's displaying here. So 2020-08-23, and then the time. I've built a little spinner on the end just to make things a little bit more interesting, and then on the bottom there we have a Unix clock, which is pretty cool. Let's take a look at the code for that. The code's a little bit more involved, but not really much so. It's relatively, once you get to grips with this thing, you can display anything you want on there. So we've got the usual garb up the top, import time. We want the date as well, so I'm importing date time. Set up the serial, set the region, CLS. We've got a splash screen set up just for the laugh. You'll have seen when the clock started up, it displays Leslie's Lab, Raspberry Pi clock, and then times out after 3 seconds. It does a CLS. And then we've got the main clock sequence itself. To get the little spinner on the end, the clock's stopped now because I press Control and C. You can actually see it's a horizontal line. This is the set of characters for the clock. So basically, we write a string with all of the characters we expect to see in a sequence. So we've got a vertical line followed by a forward slash, followed by a horizontal line, followed by another forward slash, followed by a vertical line. And you can see that if you were to display each of those characters in turn in a single place on the display, we'd get the impression of a rotating spinner thing. If you've done very much with Linux, This is actually quite a common thing that terminals display to say, hey, I'm doing something. So we set spin to equal to 0 because we want to iterate over this string. Go and grab the date, date and time, go and format it in some sort of sensible way, and then just serial write out our escape sequence, followed by now, which is our current date, plus spinner, square bracket spin. So if spin is 0, then we're looking at the 0th character out of the string, which is the vertical line, and we'll see later on we do a spin plus equals 1 later on, so now spin becomes 1, so it'll display the second character, first character, second character, third character, fourth character, and so on. And it just loops over. It loops over down at the bottom. We've got, if spin happens to be larger than the length of the string, just reset it back to 0, so it just starts over again. That's that. Unix time, same job. We just go and grab Unix time. We've rounded it to 1 decimal place. It's silly to display hundreds, and in fact the baud rate on this is so slow that the hundreds looks like it skips and pauses and all sorts of weird stuff. So we just got rid of that. And then we just write Unix time to line 2. Job done. That's it. So we've got some other cool scripts in here as well. I've built a Larson scanner, which is a little bit more complicated. Again, read the BA63 manual. So here it is. So we've got an asterisk essentially moving backwards and forwards along the display. If we take a look at the code for that, whoops, helpful to spell nano. Again, usual serial setup, and this is the code. So it's slightly different. I've written a function here where we just pass in a delay, like how fast do we want the thing to go. We've got a text to display, which is just an asterisk, and then we say while true. So we're going to loop over and over. We've got a couple of for loops in there that go I in range 20. It says basically draw this character at the 0th position. So our position is defined with this escape string. We pass in the position. So we're saying escape bracket 1, which is line 1. The position is going to be like 1 in this case, because we set position to 1 straight up. And then as we loop back round, position will become 2 and 3 and 4 and 5 and 6. The thing we've also got to do is every time we write a new character to display, if we want a Larson scanner, we've got to delete the character that comes that was displayed previously. So this is what this section does here. It essentially says, well, we're done with this character now, let's yank it out. And that's that. So this whole section, this for loop, essentially draws a single asterisk that sort of creeps along the first line there. When we've done with that, we've got to the end of the display. Obviously we want to go backwards. So we do the same thing here, except in reverse. So now we draw our asterisk at the next position on the display and delete the old one and so on. And we just go backwards and forwards like that. So that's that. But it makes for a pretty effective, cool display. We've got an example of a scroller. There's a number of scrollers. I'm not going to spend time going through every single one of these, but there's a scroller down here. Which demonstrates scrolling text. So, on line 1 we've just got BA63 RPI display, and then we've got this rippling effect down at the bottom. It's just a string of ASCII characters that scroll through the display, and that's it. We'll take a look at the code for this, just to see how this is done, and the rest of these, sort of go the same way. We've got a dual scroll example, so we're scrolling on both lines. We've got a scroll clock, so we have a clock with some scrolling text. We've got scroll left-right example, but if you can get to grips with how the scrolling works, everything else will fall into place. So we want to take a look at that. So we've got our usual setup stuff, all our escape sequences set up and so on. We've got the text display on line 1, which says RPI display, and we've got some text, which is actually our rippling text at the bottom. So it's just a sequence of characters that, when it's animated, gives the impression of rippling. And to scroll the text itself, there's a couple of ways we can do this. We've already seen that we can write to specific characters on the display. I kind of figured that would be quite slow, certainly tedious to write the thing. So what I decided to do is get the text string to behave as a circular array, as it were. So basically, if we were to display the text hello, we could say, well, let's display the text hello, and then we can remove the H off of hello and just tack it onto the end and display it again, and then remove the E off the beginning of our new hello, and then tack that on the end. So this is all that does. So there's a couple of things that happen in here. If our text happens to be quite short, if we put hello, we actually want to pad that out with spaces so that the word hello appears over here, and then we have space to the end of the display. So that's all that this section really does. It just tidies things up when we're trying to scroll text. That's that. And then we do our scrolling, and it's just basically very, very simply in Python, text strings are treated as lists or arrays, if you prefer to think in terms of arrays. So we're just saying, hey, yank the first character off our list, stick it on the end, and just keep doing that every time we enter the loop. That's it. So that's that job. There's another couple of bits and pieces that just tidy things up. When I was playing around with this, it says, for example, here, only try and display the portion of the text that will fit on the display. So if we happen to have War and Peace, for example, as our text string, it's not going to try and display all of it on the display. It's just going to display a little window, essentially, of the text. So the first few characters that we're looking at there. If we try and fire too many characters at the display, all sorts of weird things happen. It starts writing all characters to the last character on the display and things like that. So that's all that does. Thanks for watching this episode of Les's Lab. I'll put a link to my GitHub down below where you can get all the Python scripts for this project. If you go onto my GitHub page, you'll also see photographs of where to attach the wires. There's a little discussion about how things work and why things work the way they do. There's also a link to the data sheets for this particular display and the TEMIC microcontroller as well. If you want to see more projects like this, don't forget to hit like and subscribe down below. I've got loads of cool stuff lined up over the next coming months, so see you guys next time.